As part of my experimenting with supercapacitors project, I built a supercapacitor magic meter. It has 6 modes selected by this switch here. There are 2 banana jacks for the capacitor to be tested. There's a power connector here, and it all snaps together. So let's just show the modes. It says supercapacitor magic meter. This is the voltmeter mode, and it's just floating voltages there. So I should hook up a capacitor. And it's showing 2.263 volts for this particular capacitor. It's already partially charged. If I put it into one of the measurement modes, we have the lithium ion capacitor mode, and then there's a EDLC capacitor mode. Then there's a ESR mode to measure the equivalent series resistance. And then there's just a charging mode and a discharging mode. So let's run through those initially. So here we can see that it's charging, and here we are discharging. So it's discharging at 100 milliamps, and you can see the voltage monotonically decreasing. So it's 2.293 and decreasing slowly because it's only 100 milliamps discharge current. This is a 7 farad capacitor. So the charging mode is a little quicker. This is 100.1 milliamps, and you can see that we've got about 4 digits of accuracy or resolution on the current measurement, and 4 digits, at least 4 digits of stable voltage measurement. So it charges much quicker, and when it gets close to 2.4 volts, there's not enough headroom to keep this over 100 milliamps, so you can see the current is decreasing as it gets higher and higher. So in the ESR mode, anything over 2.3 volts, and it will be measuring ESR, and it's taking a bunch of measurements here. I think it's 128 measurements to average out the ESR and try and get a good idea. Now this particular capacitor has an ESR, a DC ESR of something like 80 milliohms, and this is still saying it's 30 milliohms. The AC ESR for this capacitor is about 55 milliohms, and but the way I measure ohms here is different from the way everybody else does it probably. What I do is I charge the voltage up, and I measure, I turn off all the discharging and charging, I measure the voltage, and then I turn on discharging at 100 milliamps, and then I immediately measure the voltage to see the voltage difference between when it has no charging and when it has a 100 milliamp discharge. And there's a voltage difference immediately because there's a voltage drop across the ESR, and that's what I'm trying to measure. So I measure the current and that voltage difference between when it's not charging or not discharging and when it's discharging. So I don't know if that's accurate, but it's not exactly the way they would measure a DC ESR or AC ESR for that matter, but it's the way I do it. So over here we have the EDLC meter mode, and that one takes a long time because you can see it's very slowly discharging here. The lithium ion capacitor mode is quicker to measure capacitance, but it's still going to have to discharge all the way to 2.2 volts, so it's still at 2.3 and discharging very slowly. So I'll probably cut out a little bit of this video so we don't have to wait for this to discharge the whole time. But it takes a long time for this thing to make a measurement on these large capacitors. Okay, it's approaching 2.2 volts and it should give us a reading. So here it's saying it's 11.7 farads. And the actual capacitance in the data sheet says it's a 7 farad capacitor. So it's reading a little high. I'm not sure exactly why yet. The data sheet says, you know, there's a 30% margin on the measurement, the nominal measurement. So it's possible that this is right on the edge of that 30%, but I'm going to let it run through a couple of times to see if it's always reading the same capacitance. So right now it's running through its second pass at reading the capacitance. Okay, it did its second reading and it's 8.5 farads when it's nominally 7, so it's coming closer. One thing you can notice on the meter is that although this is indicating that it's the lithium ion capacitance mode, the discharge LED is also on because that's what it's doing when it's measuring this particular capacitor. And when it goes into charging mode, the charging light will come on. So when it gets to 2.2 volts, you'll see the charging light come on to bring it back up to 2.3 volts. And the difference between the lithium ion capacitance meter mode and the EDLC mode is really just that the EDLC mode measures over a much wider voltage range. But a lithium ion capacitor, we don't want it to go much below 2.2, which is where it's going now. And then we get a new reading, 8.4 farads. So now it's stabilized at around 8.4, 8.5 farads, which is on this nominal 7 farad capacitor. Okay, I put in a 10 farad capacitor and you can see it's in charging mode. It's 1.6 volts right now, and you can see the charging current is 148 milliamps. (10 farads) takes a long time to charge up. And here you can see at 2.1 volts, the current is starting to drop. So it doesn't have enough overhead room to charge it to its full 147 or 148 milliamps. So I believe we only need it to go to 2.3. So let's go to a lithium ion capacitance meter. So it's charging up to 2.3, maybe 2.4, not sure exactly. But the charging current is down to 90 milliamps. And now it's starting its measurement at 100 milliamps discharge curve. And the lithium ion capacitance mode, it only goes down to 2.2. which is there, and it's saying 3.3 farads. So we'll just see if that first reading was a little bit off, and let it run for a little bit here. So this is a 10 farad capacitor, and I'm noticing an interesting effect. I just took it out of the box and it was discharged. So every pass through on the meter here, which never lets the voltage go below 2.2 volts, the capacitance has been increasing. And I think this is a feature of these high capacitance EDLC capacitors, that they will increase their capacitance as they spend more time at voltage. And the recommended procedure for testing them is to let them soak at their rated voltage for at least 30 minutes before doing the capacitance measurement. So I didn't do that with this one, and it's showing that the capacitance is increasing as time goes on. So it takes several minutes for each pass, and we can see that the voltage is, or the capacitance is actually increasing over time. That's very interesting. So it's at 7.7 farads, and now it's 8. So it's continuing to climb. So how about that? After a few more cycles, the capacitance reading is now over 10 farads, and that's a 10 farad capacitor. So I guess it's true that it does need to soak for a while at voltage before it reaches its full capacitance. That's an interesting property of supercapacitors. And I'm pretty happy that the meter can actually show this kind of thing. I'm going to let it run for a while just to see exactly sort of how much it's going to increase. At the same time, I have its sister capacitor of the same value soaking at voltage. So it's being run by a current limited power supply to 2.4 volts. And I will pop it in here and measure the capacitance off the bat, and I expect it to already be in that 10 farad range. But this is great that the meter can actually measure supercapacitors. I have a lot of meters that cannot do that. Okay, it's reached it's reached 10.706 farads, and it's going up very slowly now. So I'm going to pop in the other capacitor, which hasn't really soaked for a full half hour, but I just want to see if it's already mostly there. And it will take a couple cycles to settle out. Okay, the sister capacitor that's supposed to be 10 farads is reading 13.2 farads. And I can even tell by eye that the discharge at 100 milliamps is slower than the other one. So it's a little bit higher capacitance, but it exceeds the rating that it was, its nominal rating. So I've got the first capacitor soaking at 2.4 volts just to see if it will go to a higher capacitance reading as soon as I've finished this test. I guess one thing to notice is that the LEDs, the first 4 LEDs are for indicating the mode of the charge-discharge or the capacitance meter, and the other 2 LEDs, although they are a mode of charging and discharging, they are also indicating when these measurement modes are using charging and discharging. So I did have a better label made up which had all of those LEDs labeled properly, and I was going to use this new technique of transferring a toner, a laser printed toner, to the face of the meter. And I had been experimenting with a piece of well, just printing on top of the transparency to see if I could transfer the toner. That did not work. It didn't transfer any of the toner. It should have looked like this, but the toner is still on the transparency, and it didn't transfer to the PLA plastic. Now, I've seen people do this on YouTube, but the one guy said he got it to work, said he tried dozens of times before he found the magic, but he never explained what the secret sauce was. So I assume it's just cranking up the temperature until it transfers properly. But that's for another day. I will get that working if it's possible with my setup. But for now, I just 3D printed this label for the supercapacitor title, but it's not very nice looking. I'm going to figure out a better way to do labels than that eventually. However, the meter itself seems to be working very well. I like the way it's working. It's got a nice stable accuracy, 4 digits or so, and it's even reading capacitance in the right range. So far it's in good shape. So the charging rate is a bit weird. I haven't spent much time trying to calibrate that. I'm mostly measuring on the discharge. So the charging rate is a bit weird because there's not a lot of headroom to create that constant current, and sometimes it seems to jump around a bit. But I'm looking at the power supply, and it's not jumping around as much as my meter. So I'll sort that out eventually, but it's not important for measurement of the capacitance. I really am focused on doing that during the discharge cycle. So let's just hang in there for a few seconds to see if this goes down at all. From 13.3 farads, boom, it's 13.4 farads. So it's nice and stable. This capacitor is a bit higher than the other one. Okay, I put the first 10 farad capacitor back in the test after soaking it at 2.4 volts, and its reading came up to 10.9 farads. From it was just creeping up to 10.7 when we put it under that soak condition. So I think this is where it's going to end up, somewhere around 10.8, 10.9. The first cycle through after soaking it was at 11, and now it's down at 10.9. So eventually, if it's working in this range of 2.2 to 2.3 volts, the working capacitance will be somewhere around 10.8 farads. So that's really good. The meter seems to be even more accurate than I need, because the working conditions for the capacitor are kind of dictating the capacitance, and the meter is good enough to point that out. So far it's looking great. I'm happy that the meter fits into a nice little package and it's doing what I want.